Okay, in this video, we're going to review polynomials. Now, first off, we're going to start out with a one-term polynomial called a monomial. A monomial is a number, a variable, or a product of a number and a variable. Some examples, you might have a single number like -7, or you might have a variable x or x squared, or you might have the product like -7 x squared y to the third. So those are called monomials. The biggest thing to remember about a monomial is they're single terms. There's no pluses or minuses. You're not combining several of them together. We're going to use our exponent rules to simplify these monomial expressions. So let's go through and remind you about these exponent rules. First off, your product rule says if you have some number or variable to a power, let's do an m power, and you multiply times the same number or variable to a different power, the rule is you're actually going to count how many total you have by just adding the exponents together, a to the n plus n. Example, be like x squared times x to the third. You have 2x's times 3 more x's, that's a total of 5x's. Okay. Power rule, that's like a to a power raised to another power. If you have a power raised to a power, to find out how many a's you have, then you will multiply m times n. Example, x squared to the fourth power. That's like x squared, x squared, x squared, x squared. Again, you're adding, in that case, to find out how many total you have. Or you can just say, if I have 2 or 4 2's, then I have 8 of them. You're going to multiply those powers together. Quotient rule, I have 2 different versions of the quotient rule. I do it a little bit different. I have a to the m over a to the n. Let's say that m's a larger number. So I have more a's on top than I do on bottom. What you're going to do is you're going to subtract m minus n. If there's more a's on top, then you're going to do this number minus this number. However, I do it different because I say if there's more a's on bottom. What if a to the m is on bottom and a to the n is on top? If m's a larger number, you're still going to subtract, but if there's more on bottom, you put your answer on bottom. And you'll put, if nothing's left on top, you'll put a 1 on top. So here's both of those scenarios. X to the fifth over x to the second. There's 5 x's on top, 2 on bottom. Let's subtract. Since there's more on top, put your answer on top. So really, you don't even need a bottom. You could put over 1, but you don't have to. If it was x to the second over x to the fifth, you do the exact same thing. You do 5 minus 2. However, since there's more on bottom, you'll put your answer on bottom. You'd put a 1 on top. Next up, your negative exponent rule says if you have an a to a negative exponent, here's how you make a negative exponent positive. You draw a fraction bar, you bring it to the bottom. If it's a to the negative m on top, then it's a to the positive m on bottom. Let me write that again. If there's nothing left on top, you always put a 1. The other version of that, what if it's an a to the negative m on bottom and a 1 on top? To get a negative exponent to be positive, you simply move it across that fraction bar. So if it's on bottom, you move it up to the top. Or the last scenario, what if it is a fraction? Let's do a over b to the negative m power. If it's a fraction raised to a negative, what you're going to do is you're going to flip your fraction and change the negative to a positive. So there's the 3 different scenarios. And here they are. For example, x to the negative 3. Fraction bar, bring it to the bottom. That's going to be 1 over x to the positive 3. Or if you have 1 over x to the negative 3, to make that negative exponent positive, you'll bring it to the top, and it'll be x to the third over 1, which you don't have to put the 1 on bottom. Or if you have 1/2 to the negative 2 power, that's the same thing as 2 over 1, or just 2 to the positive 2 power. And then the last 0 exponent rule, the easiest of all of them, anything to the 0 power is 1. A lot of people get that mixed up and they say it's equal to 0, but it's not. Anything to the 0, whether it be x to the 0 is 1, 2 to the 0 is 1, or a squared b to the 0 power, anything to the 0 power is always 1. Okay, next up we're going to multiply. We're going to use these rules, and they do make a note. Remember, when you're adding or subtracting monomials, you just simply combine like terms. Okay, so we will have to go back and do some of that in some of these problems. However, if you're just multiplying, what I want you to view is there's 4 different things being multiplied here together. So what you're going to do is you simply multiply what you can. I can do 5 times -7, that's negative 35. And then you count your x's. There's 2 x's, 6 more x's, that's a total of 8 x's, and you're done. Negative 2 eighths to the third b is all being raised to the second power. So here's your power rule. So you're going to raise all three of these. Now notice there's no plus or minuses. If there's a plus or minus, this has to be distributed or FOILed. There's not. So you're just going to raise all three of these to the second. Negative 2 to the second is 4. A to the third to the second, you're going to multiply those exponents together, gives you a to the sixth. B to the first raised to the second is b to the second. And then you have times 8ab to the ninth. And then you do the same thing you did on the last problem. 4 times 8 is 32. Count your a's. There's 6 and 1, so that's a total of 7 a's. Count your b's, and there's a total of 11 b's. Number 3. Now this is where the combining like term stuff comes in, because you have two terms here. You have this whole first term here being divided, and then you have minus another term. So let's take that first term, draw our fraction bar. Let's start with our numbers. 54 divided by 3 is 18. 18 over 1, or just 18. You have 6 m's on top, 2 m's on bottom. You subtract them. That leaves you with 4. Put your answer on top because there's more on top. 4 n's on top, 1 n on bottom. Subtract them. That leaves you with 3 n's. So really, you don't need a fraction bar. Minus 10 m to the fourth n to the third. Now, addition and subtraction, this is not a this is a monomial here and a monomial here, but the whole problem is not a monomial. We'll talk in a second. This is actually a binomial. You can only add or subtract these if they are like terms, meaning the variables must be identical. M to the fourth, n to the third, and they are. You have 18 minus 10, which gives you 8. When you add or subtract like terms, the variables stay the same. Not when you're multiplying and dividing, but if you add and subtract, leave the variables the same. Number 4, multiply the 2 times 10 gives you 20. Add, see how many k's you have. You have 4 and then negative 7. That would be k to the negative 3. We're not going to leave our answer like this because we have a negative exponent. To make a negative exponent positive, you need a fraction bar. Only the part with the negative exponent moves. So the k to the negative 3 is all that you're going to move. It becomes k to the positive 3 on bottom. The 20 stays on top. Number 5. First set of parentheses, everything being raised to the second power. There's no plus or minuses, so we just raise everything to the second. To raise a fraction to the second, you square the top, square the bottom, and that's it. R squared to the second, you're going to multiply, and you got 2 times 2 is 4. S to the seventh to the second, multiply 7 times 2 gives you 14. Times, these second set of parentheses are really not necessary. 1/6 R to the third S. Multiply together what you can. 4/9 and 1/6, we can cross cancel there. Divide by 2, divide by 2. And that gives you a 2 over 27 when you multiply the fractions. Now let's count your R's. There are 7 of them. And count your S's. 14 and 1 gives you 15 S's. Number 6. Always start on the inside and clean up the inside of your fraction bars or inside of your parentheses first. If you can, 14 divided by 7 is 2 over 1. You have 12 W's, 3 W's, subtract them. That leaves you with 9 W's on top. So nothing's left on bottom. But then to raise it to a negative exponent, you must now flip it. 1 over 2 W to the ninth, and then it's raised to the first power, which that's not really going to change it. So you're done. Number 7. Fraction bar. 15 over 24. 15 divided by 24 is going to give you a decimal. So instead of dividing it, we're going to reduce it. Divide by 3 and divide by 3. Gives you 5 and an 8. Now let's count your x's. There's 10 on top, 12 on bottom. There's more on bottom. When you subtract, you're going to leave your answer on bottom. Y to the fourth over y to the third. There's more y's on top. So when you subtract, leave your answer on top. And you're done. Number 8. Again, clean up the inside of these fraction bars first. So you have 1c on top, there's 2 on bottom. Cancel them out, subtract. 2 minus 1 leaves you with 1 on bottom. So you have 1 over c to the fourth times, I'm just going to rewrite this because I'm going to have to raise that first one to the fourth anyway. So there's what you now have. So in the first set of parentheses, raise everything to the fourth, leaves you with a 1 and a c to the fourth, and you don't need parentheses anymore. Times, raise everything here to the fourth, negative 3 to the fourth gives you an 81 and a c to the fourth. Now you've got to multiply these together, so let's put that over 1. You can cross cancel. These c's and these c's, when you subtract them, leaves you with no c's. So therefore, there's no c's left. Multiply the tops together, multiply bottoms, leaves you an 81 over 1, which is just 81. Okay, number 9 says, give an example of two monomials with a quotient of -3 n squared m. So what could we simplify that would give us -3 n squared m? So let me draw a fraction bar. First off, the -3, I don't know, there's several answers that you could put here. I know that -6 divided by 2 would be a -3, so we're just working backwards here. You got two n's on top, so you might have started with like 6 n's on top and maybe 4 on bottom, and that would have left you with 2 n's on top. There's one m on bottom, so that means that the quotient you started with had one more on bottom, maybe m to the 5th on bottom and m to the 4th on top. And the other example would be very similar to that. I'll leave that up to you. Polynomials now. A monomial had a single term, so therefore a polynomial has many terms. A polynomial is the sum or difference, it has plus or minus signs, of many monomials. The highest exponent of a polynomial is called the degree of that polynomial. The standard form of a polynomial, you just need to make sure to always write your exponents in descending order. So you're simply going to start with the highest power of the variables and just decrease them thereafter. So we're going to write a few polynomials here in standard form. We have all k's here, so let's start with the highest power of k, which is a 5. So that's going to be -k to the 5th first. Then we look for any k to the 4th, there are none. So now we're going to move on to k to the 3rd, so -3k to the 3rd. Then our k to the 2nd would be +1/4, k to the 2nd. Then you have a k to the 1st, so plus 8k, and that constant is always going to be last -1. Second, we're going to start, let's see, we have a squared, b squared. We're going to start with our highest power of a, though. Let's look at all of our a's. Let's look at alphabetical order. Look at the ones that has the most a's. So we're going to be 4a to the 3rd. Then we're going to look for our a squareds, and that would be right here, plus 18a squared b squared. Then we're looking for our a to the 1st power, which is plus 7ab, and then our minus b squared because it is no a's. Next one, look at your x's first alphabetically. We're going to use x. So that's going to be, here's my x to the 3rd, so 9x to the 3rd y comes first. Then my x squareds will be minus x squared. Then x to the 1st would be right here, so plus 5xy squared. And these two, neither one of them have x's. So then I'm going to move on to my y's, and this one has 4 y's, and my constant will always be last. Now let's classify these. Let's talk about the different names for my polynomials. And some of these names, again, you've already heard, but based on degrees, based on the highest power of x or y, this is how we classify these by degrees. If your highest power is a 0, this is called a constant. I've already used that word several times. A constant has no x's and no y's. It's just a number, and that number never changes. That's the reason we call it a constant. If its highest power is 1, it is known as linear. Root word is line. That's like y equals mx plus b, x to the 1st power. 2 is your quadratic, which we already know when we graph is a parabola. X to the 3rd would be cubic. X to the 4th is quartic, like 4 quarts in a gallon. And x to the 5 would be quintic. Then, based on how many terms you have, we've already used the word monomial once, but if it has a one-term polynomial, it is a monomial. We know that bi means 2, so a binomial would have 2 terms, so we already know what has 3. That would be a trinomial. And anything 4 and more is just a plain old polynomial. And all of those are polynomials. We just have no special names if it has 4 or more terms. So now let's name some of these. Polynomials are classified by degree. Again, the highest exponent is your degree. And the number of terms, we're going to use the chart that we just made to classify each polynomial below. So -3x plus 1, the highest power is 1, and it has 2 terms. So this would be linear because of the 1, and a binomial. Okay, the second one, your highest power is a 5. So that would make it quintic, and it has 3 terms here. So that'd be a quintic trinomial. The next one, your highest power of x, would be 0. There's no x's, there's no y's, so therefore this would be a constant, and since there's only one, and a constant's always going to be one termed, right? So it's going to be a constant monomial. Okay, number 16, highest power of x is x to the third, which makes it cubic, and there are 4 terms, so that would be a cubic polynomial. Okay, the next one, highest power, we know this is a parabola because of the x squared, so that makes it quadratic, and it is a quadratic trinomial, and we've factored several quadratic trinomials. The next one has no plus or minus signs, just a negative sign there, so this is a monomial. The highest power is a 4, so that'd be a quartic monomial. Okay, next up, number 19 says, give an example of a cubic. So automatically we have to have like an x to the third, a cubic binomial. So just tack on anything, plus 3 if you'd like to. So that'd be a cubic binomial. Give an example of a linear monomial. Since it's linear, like 3x, it has to be to the first power. Since it's monomial, don't add anything to it because it only has one term.